All right, guys. So here is our little presentation on energy. Okay, so the very first thing I have up there as the thing that we've been talking about over and over and over is energy. Can you create it? Can you destroy it? Think about that for a second. See if you can come up with a way to defend it. I think obviously at this point we know that you can't create it, you can't destroy it, but can you defend that idea? And I want you to think back to some of the labs, some of the different things we've been talking about how everything is just transformed, transitioned from one form of energy into another. Let's go ahead and start looking through some of this. What is energy, right? Energy is the ability to do work, and it cannot be created, it cannot be destroyed. Think about, if you're a Marvel fan, think about Thanos here. You know, the big quote from Thanos, at least in the movies, is "I am inevitable," right? So is energy. It's going to be there. It can't be created, it can't be destroyed. It is just here, always, just shifting back and forth between different forms. How do we divide all that energy? Well, the big ones that you guys know of are kinetic and potential. Those ones that should be kind of familiar. You've got energy that is stored, but we also have energy of motion. When you take all of those kind of ideas and put them together, that's what we would call mechanical energy. You kind of take the mechanical energy and some of it becomes stored, some of it becomes motion, and that is all the energy on the earth. What is potential energy? Well, it's the stored energy. So think about stretching back a rubber band and feeling that tension. That is stored potential energy. When you have water sitting at the top of a waterfall or yo-yo in your hand getting ready to go down, like these are moments of potential energy. Even a bow and arrow is potential energy. When you pull back on that bow, it's got the potential to be launched out of your hands. Interesting is when you talk about potential energy, if you lift an object up higher, so this right here has less potential energy than this. The higher up you have something, the more potential. That's because it has more potential to fall down a little bit further, a little bit faster. It has the ability to transition into something else a little bit more. Also, the more mass something has, the more potential energy it is. Think about the difference between a car and a truck. A truck has more mass, therefore, it automatically has more energy stored within it. It has more potential energy. Let's practice. If you wanted to drop an apple from the top of one of these three items, where will there be the most potential? At the top of a tall building, at the top of a chair, or at the top of a crane? Hopefully, after hearing what we just talked about, the answer is A, right? You'll have it at the top of a tall building. The higher the object, the more potential energy it has. Now, the opposite of potential is kinetic, the energy of a moving object. Something that has the most kinetic energy is when its movement is the greatest. When it has the least potential energy, it is when it has the most kinetic. So let me say that again. An object that has the most kinetic is when its movement is the greatest. However, when an object has the least amount of potential energy, that's when it has the most kinetic. So these things kind of work like this, where when one goes down, the other one comes up. So as your potential energy decreases, your kinetic energy is increasing. If we look at this on a roller coaster, we can sit there and say, okay, well, when does the train on this roller coaster have the most potential? You should, at this point, understand that it is when it is at the very top. Okay? The higher the train is, the more potential. At the top, it has a huge amount of potential, but very little kinetic. Now, when the roller coaster starts to move, you'll start to see that potential transition into kinetic. Okay, let me go ahead and show you this example. Let me get my face. Whoa, where is it? Oh, there we go. Okay, this is just a cool example that I want to show you guys. But what we'll see here is watch this pie chart in here. Okay. And I think what we'll do is we'll take it step by step. You can kind of see how those things change. So when I hit step, I want you to watch how this pie chart fills with potential energy. As it goes up the hill, it gets to its highest point. That means we're at maximum 100% potential energy. As we go down to the next step, it's going to transition. The majority of that potential energy has now become kinetic energy. Why? Because it's at one of its greatest moments of movement. All of that stored energy has transformed into kinetic energy. As we start to go a little bit back up the hill, notice how we gain a little bit more potential. As we go back up the hill even a little bit more, we transition a little bit more of that kinetic energy back into potential. And as we make it to the very bottom of the roller coaster, we're at our very maximum amount of kinetic energy here. So all of that potential that we stored back in it at step number 5 or step number 1, all of the energy that we stored here, by the time that we get down to station number 5, it has been transformed entirely into kinetic. When we go back up to station 6, notice how some of that energy has transitioned back into potential because it went up the hill again. Okay. All right. Continuing with this one. All right. Hopefully that made sense. All right. Just kind of going through some of the homework. Now, you guys have the key. So I'm not going to go through this a ton. I just want to show you, talk about some of the different answers here. But again, you guys have the key to access this here. So if you want to see the right answers, you can check it out there. Mechanical. Remember, this is a combination between potential and kinetic. So the fact that, remember, we talked about mass. A hammer has mass, especially a sledgehammer. It has a lot of mass. So when you start to move that mass, applying kinetic energy to it, you now have this thing that we call mechanical energy, a perfect combination of both kinetic and potential. The sun is always going to be nuclear. The reason why the sun is nuclear is because that is where the sun gets its energy from. The sun gets its energy from nuclear reactions. Batteries are going to be chemical. When you're falling out of the sky like a skydiver, that's going to be gravitational. Anytime you have light, we know that that is EME or electromagnetic. Of course, in this image, we see heat. That is thermal. Lightning would be electrical. And then a concert. Of course, what you hear at a concert, you hear lots of sound. So that's our sound energy. On this one, I'll just highlight a couple because I think this is exactly what we've been doing. We've been practicing these energy transformations a lot. So you kind of just figure out, where does the energy start, and then where does the energy go to? So of those forms that we just saw kind of back here, where does the energy start and where does the energy go to? So let's take, for example, the lawnmower right here. Well, where does the lawnmower get its energy? It gets it from fuel. So when we're talking about gasoline or fuel, we're always going to be talking about chemical energy. There's energy stored in the chemical bonds of that gasoline. And then when they are released, what it does is it transitions, it transforms that energy into sound. Of course, we can hear the lawnmower. It turns it into kinetic. The lawnmower moves. We got a blade on it, but it also just propels it forward. And then with that, you also get thermal. Now, thermal is a little bit of a complicated one. We should see thermal a lot. In this case, we get thermal because of the movement of those things. There's an increase in friction, and therefore we get thermal energy. Okay, let's do one more. Let's do these solar panels that right here. So with the solar panels, they receive the EME from the sun. So we're talking about number 2 right here. They receive the EME, the light from the sun, and they convert that into electrical. All right, now guys, we could do any one of these. If you have questions about some of the other ones, you're unsure of why I did what I did, please just send me an email or come and see me and let's talk about them. I want to make sure that you guys are very much understanding these different energy transformations. Remember, just to summarize here, energy is never created, energy is never destroyed. It simply moves from one form to another, which we've now seen in several examples right here. Guys, let me know if you got any questions. Otherwise, let's just keep plowing forward.